So where you see this dashed line right here, everything that's to this side of the line, this is our intranet. This is what happens within our network. Okay? What type of IPs are we going to have on here? Private IP addresses. So these are going to be .10 machines on our intranet. Okay? Now, in addition to having private IPs, because remember, private IPs aren't routable. They can't get out, so if the hacker's over there, he can't get in because we have private IP addresses. Another thing that we do is we create this password policy. An example of it is 26N. If we create a password policy of 26N, we say use 26 letters of the alphabet, which are all of the letters of the alphabet, in lowercase. So this is the abbreviation for a password policy. Use all 26 letters, all lowercase. So you can only use, when you create your password, and I just put that up there as an example, you can use any letter in the alphabet, all lowercase. As you see, there's no numbers or anything else. Okay? So 26 letters and all lowercase. That's what that means. All right? If I wanted to include numbers, I can put 0 through 9 there, and that would be our password policy. Okay? But just as an example, I just put that up there. Another thing we do on the intranet is we create these things called mandatory vacations. Mandatory vacations mean that you've been working real long on that one machine. You haven't been taking breaks. You built up a whole lot of extra hours. You're working, coming in early, you stay in late. From a security point of view, that puts up a red flag that you're doing something malicious. That you're coming in real early and you staying real late. You're not taking vacation, not during any of the holidays or anything else. So we put you on a mandatory vacation. We say, go home for 2 weeks. I don't want you, no, go home right now. We get security, they escort you out, you go home for 2 weeks. We sit somebody in your chair and we have them log in to see if we can find anything on your box. Anything, you know, and a lot of times we find that people are gambling. We find that people have a second job, or they started their own business, but they're using the work computers for their business. Or they're doing graphic, you know, if they're doing web design or editing photos as a second job. We find out that a lot of times they just have a second job. On occasion, we find some that are doing something malicious. He has downloaded secret files or moved secret files from a classified machine to an unclassified machine. So in his office, he may have this box here that has all secret, and this one is all unclassed. He's taking data from this, put it on a disk, and put it in here. And now he's getting ready to send it out. So we are able to find out fraud, any type of malicious acts that you're doing by putting you on mandatory vacation. Or if you've already taken vacation, you used a lot of days, we can do job rotations. Where we say, okay, these are your assigned seats. I want everybody to rotate one chair. So you come to the front and everybody changes chairs. Believe it or not, they'll tell. Esther will say, hey, I found this on this computer, I found this on the computer. I didn't do it, I just sat here today. And that's another way that we're able to find if there's anything malicious within our intranet. Okay? So that's covering these. Now, from this switch, so this is our symbols right here. From this switch, we have VLANs. VLANs segment isolate your network. So everything that's on VLAN 100 can only go within this range. They can't go to anybody else. So I have my wireless access coming on VLAN 100. So only wireless will be using this VLAN. If this VLAN gets attacked by a hacker, it's contained to this area, to this VLAN. It doesn't affect VLAN 200, and it doesn't affect my users here. Okay? So that's the purpose of VLAN. VLAN segment our network so that, like I said, it isolates it, contains it into one area. Now, on this switch here, in order to some of the security features that we put on switch are access control lists. Now, access control lists can, even though the port is hot, if you don't match up with that IP address or whatever we put in there, you will not have connectivity. You will not be able to get a signal in order to use the wireless network. So access control list is, think of a bouncer standing at the door. If you match, he looks at your name tag, so okay, your name is on the list, you can come in, you have access to the club or whatever. That's an access control list. Even if the ports are hot, it can still block you if your name isn't on that list. Okay, everybody got that access control list. The next that work hand in hand with access control list is MAC filtering. MAC filtering does the same thing, except if you don't match that MAC address, then you're not permitted to come in. So throughout this building, let's say the ECPI building, they have multiple access points, APs. Each access point could be assigned to a classroom. So if you take your wireless device and you move from this classroom to the next classroom, your MAC address isn't on their access point, so you'll get a signal, but you won't be able to log in or anything else. It's only matching up with the access, with your MAC address on the access point that you're assigned to. Okay? So that's VLANs, that's access control list, MAC filtering, and that's our access points for our Wi-Fi. All right? I put the printers on this set on VLANs. Printers, video, any type of external thing, put them on their own VLANs. Because most of the time, those are the ones that hackers are going to go after. Printers, voice, things like that. They're going to look for that. The next thing that I'm moving up is this thing called a NAC, Network Access Controller. Our NAC serves as our last defense before it gets into our intranet or into our environment. What this NAC does is the NAC looks to make sure that your applications are up to date. So as you're coming in to our network, it gets to the NAC says, is your antivirus up to date? We're running 8.9. What are you running? You're running 8.8, you're denied. You cannot come into this environment. Or your Java's outdated. Or your media, everything, it checks everything that's on the device as that machine requests access to come in. And if those applications aren't to the standard that's inside of our environment, this NAC prevents it from coming in. Does everybody understand it? So if I'm running, like I said, if I'm running McAfee, and I have McAfee 8.9, and you come in at 8.8, it's going to be denied. It's going to tell you you're not compliant, update it, and try again. So the NAC isn't going to let devices that aren't properly patched to the level that's on the intranet here come into our environment. All right, moving forward, we have our proxy server. So remember, if I'm doing private IP addresses here, that proxy server is going to give me what type of IP address?
Public IP.
Public IP address. So it's going to give me a public IP address so I can go out to the public and get to the internet. So let me draw this real quick. This is the internet. All right. So it's going to give me a public IP address so I can get out and get to the internet. Now, the proxy server also has a white list and a black list. A white list and a black list. A white list is a list of authorized sites where you are permitted to go to. So as you're going out, even though it gave you an IP address, public IP address, to go out to the internet, it's on. If I incorporate a white list, you can only go to those sites that's on this list. The black list is you can go to any site except for the ones on the black list. So I can incorporate a black list and a white list on this server to prevent you, or to say, okay, you're permitted to go here, you're denied from going to these sites. All right? From there, it goes out the router. The router can do the same thing, but the router mainly is forwarding packages so you can get out. The next is our IPS. IPS. What is an IPS? IPS is intrusion So the job of the IPS is, if it makes it through everything else, then it's going to stop us at the IPS. Protection, prevention. Sorry. So it's going to prevent anything from coming through. If it made it through these devices, it's going to stop it here. So we set this rule up. So if we set a rule to say, look for IPv6, what is this in hex? What is this in hex? If I draw this line, maybe it helps. You have 4 ones and 4 ones.
FF.
If I set a rule that says, look for 3, 6, 7 Fs. It makes it through. It gets here, it says, I see 7 Fs, block that traffic. You're not going any further. So it made it through the other ones, but I set a rule here that says, deny it. If it tries to come in with all Fs, or 7 Fs, or more, deny it. So this is one of the last defenses before. Now this is only checking applications. This is checking actual packets. So this is rule set. This is basically whatever applications that I'm running. Okay? But our IPS blocks it. You can't come in. You didn't meet this, or I recognize you as being malicious, so you can't come in. The next is IDS. Our IDS is intrusion detection. So the only thing it's going to do is pick up things that didn't, or it's going to pick up traffic that may have made it through the firewalls. So the way we test our firewall to see if our firewall rules are working is we stick an IDS here, and if the IDS picks up something, then our rules are messed up on our firewalls. Because it's only set up to detect things that are malicious. Right? So the next is our 2 firewalls. Individually, this is a firewall, this is a firewall. When I put them 2 together, this middle area here is called a DMZ. Demilitarized zone. So you may have to take another picture. So the DMZ is this area between the 2 firewalls. Right? Now, where else is a DMZ? Does anybody know? Between North and South Korea, there's a DMZ. That's an area that neither country is allowed to come into because of their conflict. So the north side can't come into it. It's just in the area in between the 2 countries. It's heavily guarded on both sides. The south looks at the north looks at the south, and they make sure that neither one of them crossing that middle area. In networking, we have a DMZ also. It's where 2 firewalls come together, and this middle area is almost like a little safe haven, because any traffic that wants to get information from back here, it would have to travel all the way there, all the way back to here. That's a lot of openings if we let it to come all the way back. It's a lot of opportunities to get hacked. So we create this DMZ, and we put a server in there, and this server talks back to one of these servers. So let's say, let me stick a server here. So it gets information from this server. It says, hey, you got any updates for me? Yeah, I got an update. Pushes the update to you. We call this a zone transfer a lot of times. And DNS is one of the main things. So we send the information up to this server so that a person that's sitting down here in this computer, this is a client, he doesn't have to travel all the way back to this server to get information. We stick a server in the militarized zone in the DMZ area, and he just goes to there, right? And he can get the same information, or just a scaled down version of what he can get from here. This one has housed all of the information, and it pushes up the information that we want to release to this server so that they can just come this far to get the information. Some people put their email server there. They'll put an email server here. They may have an email server back here. It depends. I mean, you can put it either place. A lot of people put it here so that they don't have to go all the way to the back to get their email. It's a lot quicker. It's a lot safer. All right. Now, we have our two firewalls that makes up our DMZ. On our firewalls, we have two types of rules that we use. We have the explicit rule, which is explicitly saying you are not permitted to come in. It's similar to what we have in our blacklist. Explicit, you cannot come in, you cannot come to my class. If I told a student that you cannot come to my class, I'm explicitly saying. Implicit is not identified by the rule. So if I said, only my students can come into my classroom. See how that's implied? That only my students, meaning no one else. I didn't explicitly say, you can't come in, you can't come in. I just implied that they couldn't come in because I said only my students can come in. Does everybody get that? A lot of people confuse implicit and explicit. Explicit, I'm stating, y'all cannot come in my class. Implied to the same group, only my students assigned to me can come to class. So that group that's over here, they're implied that they can't come in. Okay? You good? Okay. Good? Smile so I can just, okay, you good. All right. So that's implicit and explicit. Remember, implicit, it's not identified by the rules. I never said that they couldn't come in. I just said only my class. It's implied. Okay? So those are the rules that go down to our firewall. Inside that DMZ, like I said, this is a safe area. Now, these firewalls have 3 states for this class that we cover. A stateful, packet filter, and an application. A stateful is just like, I have a daughter. When she used to go to high school, I used to see what clothes she wore when she left to make sure those are the same clothes she wore when she came home. That's stateful. So if a computer that's in my intranet goes out, it hits a stateful firewall. That firewall gives it a little marker and says, okay, I know that you're coming out, so I'm expecting to see that marker come back in. So it's expecting that same thing to come in. So let's say that I gave it a number, 101. I'm expecting 101 to come back because it went out to look for traffic. So the computer here went out to the internet to get some information, and that information needs to come back to him so it can be displayed on his computer. With stateful, I'm expecting that connection. It went out of this IP, I'm tracking it, I assigned it a little tag, I know when it comes back, I know where it comes back in. I'm expecting. That's stateful. Okay? Like it knows what goes out, and it's expecting that same path to basically reverse and come back in. Packet filtering firewall only looks at the packet. So it's looking at the header, it's looking at the IP address. It's looking at what we call a source IP, destination IP, source port, destination port. That's mainly what it's looking at, and then of course the packet or the payload. That's it. It's just doing a quick examination. That's packet filtering. It's just looking at the packet and saying, okay, I didn't see anything. Go ahead and come in. This is one of the lowest ones. This is the highest one. So I'm going to put low. This is high. And stateful can go either one. This stateful is like an option. It can be stateful and sit on the application, or application and run by itself. But this is the highest one. With our application firewalls, that's what we got there where you're looking for anomalies. at this firewall, this is where we're looking at content. So we can say that any traffic that has anything like porn, or if it's talking about religion, whatever keywords we put in there, that firewall is going to catch on that word and say block that traffic, or deny that traffic, or